professor, physician.
Hi, I'm Dr. Tree Banerjee. In this video tutorial, I will be showing you exactly how to conduct several important statistical tests, um, one of which is a categorical variable versus a categorical variable. Um, can anybody guess what that statistical test may be? Well, if you guessed chi-square, then you were absolutely correct. Um, Alternatively, and this is just for information purposes, the z-test is in fact another statistical test that you could use in this situation. Now, if you're thinking about categorical variables and continuous variables, so your dependent variable, think about it, your dependent variable is continuous. So think about a common sort of dependent variable, a demographic dependent variable, which is also continuous. Can you think of one? So if you thought of age, then you were correct. That is one of many continuous variables. Now, body mass index is another one. These are all, of course, height, weight, all of these are excellent examples of measures of continuous variable. So if you have a continuous variable versus a categorical variable, now depending on how many categories you have on your independent variable, then that will determine what type of statistical test you will use. So in this first part, I've not only gone over two major types of statistical tests, the chi-square, which was actually one of the first ever statistical test that I actually used by hand. So this was a very fundamental and basic um, observed versus expected, so sort of chi-square calculation that I did, and it's very important. So if you base all of your understanding of statistics kind of off of one statistical test, and then in relation to that, see where other statistical tests are, that's one way to keep a lot of this learning and understanding in one place. So I do have actually very creative graphics where I've put together multiple different types of statistical tests and gone through an algorithm to show you specifically exactly where what statistical tests may apply. So now that I've talked a little bit about this, I think we're ready to do a demonstration. So if you look over here and look at, so again, you have the option of using a syntax level program, uh, write a program and run that, or alternatively, you can actually use the functionality that is available to you. So we're going to use the menu functionality that is available. And so you can look, and again, there's multiple statistical tests that you can look for and try to think of the type of statistical test that's most relevant in this situation. So you can take a look and see if table analysis may be the one that we are interested in. And of course, in the center, there will be the data set. And again, the name of this data set is suicide due to the fact that this was the suicidal ideation was in fact one major variable that was available in the National Health and Nutrition Examination Survey data set. So there's multiple variables in this data set that we're going to be looking at specifically that is related to other areas. So I just wanted to point that out that a lot of times the naming convention of the dataset does not necessarily represent what is um, included within the dataset. So it's something to keep in mind, just so that there's no confusion. So let's look for a variable that is categorical, and we know that it is categorical. So gender, and this is the typical gender variable that you can find in National Health and Nutrition Examination Survey. I actually have this variable name memorized because I have used this data set extensively and published quite a few journal articles in this area. So here is cardiovascular disease, and then you can kind of look in options and see. And if you take note what is going on the right hand side in your syntax uh, menu and syntax window, you can see chi-square, and then uh, number percent, NO row, NO column. So these are all representative of number. So you see the log, you see the code, and then you can hit run. And once you do, you can see the results gradually be populated on the right hand side. And so sometimes it takes a little bit of time. So as we're waiting, you can think of all of the different types of statistical output that we're about to see. And so as you can see, we already have output. And just a quick perusal of what is available. You have a table with the frequency distribution at the top. And so cardiovascular disease versus gender is at the top. So males versus females. And then you have some excellent examples of frequency distributions. The distribution of cardiovascular disease by gender. So if you look, then this is the distribution. And so there's also a excellent Mosaic plot, which is kind of interesting to look at because you can see the proportions, the various proportions as it pertains to the color in this rectangle. So if you look and see, then a certain proportion of gender is broken down by cardiovascular disease. So if you look males, one is males and two is females. Um, Among males, what is the percentage of cardiovascular disease? And then so you can look at this mosaic plot, and this is a nice display. And so the main finding that we're interested in is to see, so is there a significant association between gender and cardiovascular disease? That is the research question that you are looking for. And so you would, of course, go through the steps, the 5 steps that you would be going in and actually writing out the null hypothesis. So your null hypothesis would be what? Your null hypothesis would be in the situation that there is no association between gender and cardiovascular disease. So technically, the technical research null hypothesis is that there is no relationship between sex and cardiovascular disease in in this model. So there's actually, so this is biological sex that we're looking for. So that's, I think, an important point to make here. But I think we're extrapolating and saying that this is gender. So even though we conflate the two terms in this situation, I think we are actually kind of showing all of those at the same time. So the chi-square is statistically significant. So we can actually reject the null hypothesis and say that there is a significant relationship, and that P is less than the alpha that we have set. Alpha is the type 1 error that is acceptable, and that is set at 0.05, and pretty traditional. And so you have Kramer's V, and some of those to look at some of the effect sizes that you may be interested in. So not only is it significant, but the strength of the association. But in this, really, this is beyond the scope of this video, so this is not part of what you would be looking at um, in a traditional sense. But you want to make sure that you follow it up with the conclusion. So what does this mean? What are the implications? So if there are significant differences between males and females, so maybe we need to look at cardiovascular disease separately in males versus females. And so this is one of the reasons why we need to do more studies in this area. This is from start to finish a demonstration of how a chi-square would look like. Now, if you had less than about less than six or less than five in a certain category, which is not the case in our situation, but if it were to be the case, then you would use this Fisher's exact test. So the exact family of tests are an important set of tests to be thinking about when you have a lower sample size. And this is a test that I have used in the past and am currently using. And so again, so this is a statistical test that you may be looking at in this case, but not something that we are interested in this case. So now that we've gone through a whole set of instructions and demonstration, now let's switch over to looking at how you would run an analysis where there is an outcome variable which is continuous, and then a independent variable or a predictor variable which is categorical. So it may be two categories or it may be three or more categories. If we're looking at two categories, t-test will suffice. But if we're looking at three or more categories as your predictor variable, then you want to look for another test known as one-way ANOVA. And so one-way ANOVA is the one we will be exploring in this situation. And so let's make sure that the right data set is used and that we can find it in the right place. And so that is selected. And then the dependent variable is C-reactive protein. Let's take a look at that. I know in a lot of my demonstrations, I have used that as an example. And then let's look at ethnicity as the other variable. And we know that there is more than two categories here, so ANOVA is the right test to run. And of course, if you have two categories, then but you have the option then, and you want to mainly run the t-test. But when you have three or more categories, you want to work with one-way ANOVA. And so let's go through the findings quickly. It's F test, which is between divided by within. So that is kind of how you're looking at the variances and comparing the two. So is how it is, so it's usually signal versus the noise. That's how you look at the statistical test. And so that's the F value, and the P value that's corresponding to the F test is in fact statistically significant. So what this does tell you is that there is a significant relationship, but then you want to look at the comparison of the means to see where the significance lies. And so if you look, you can kind of find, and if you uh, try to determine what some of these numbers are, then you'll be able to determine where the actual difference is. So just take a look at that, and then here's a nice graphic that is created, and looking at additional sorts of information. So just take a moment to go through some of these, and just be sure to make note, like, so there's the 5 steps, and I can quickly review through those. You have to, of course, think about the research question. So does C-reactive protein, is there a significant relationship between C-reactive protein and ethnicity? Null hypothesis is that there is no statistically significant relationship. And then you want to run the actual one-way ANOVA statistical test, look at the F value, look at the corresponding P value that results from the F value. So that would be, in our case, the F, uh, well, depending on which F value you're looking for, the original F value is 8.83, and then the corresponding P value is less than 0.001. So there you have it. I have gone over the one-way ANOVA statistical test, and now you know how to run it, and more importantly, how to interpret this test. So thank you for listening.